So I've got this crazy discontinuous function here, which we'll call f of x. And my goal is to try to draw its derivative right over here. So what I'm going to need to think about is the slope of the tangent line, or the slope at each point in this curve, and then try my best to draw that slope. So let's try to tackle it. So right over here at this point, the slope is positive, and it's a good bit. It's a good bit positive. And then as we get larger and larger x's, the slope is still positive, but it's less positive. It's less positive. And all the way up to this point right over here where it becomes 0. So let's see how I could draw that over here. So over here we know that the slope must be equal to 0 right over here. Remember, over here I'm going to try to draw y is equal to f prime of x. And I'm going to assume that this is some type of a parabola, and you'll learn shortly why I had to make that assumption. But let's say that, so let's see, here the slope is quite positive. So let's say the slope is right over here. And then it gets less and less and less positive. And I'll assume it does it in a linear fashion. That's why I had to assume that it's some type of a parabola. So it gets less and less and less positive. Notice, here the slope, here for example, the slope is still positive. And so when you look at the derivative, the slope is still a positive value. But as we get larger and larger x's up to this point, the slope is getting less and less positive all the way to 0. And then the slope is getting more and more negative. And at this point, it seems like the slope is just as negative as it was positive there. So at this point right over here, the slope is just as negative as it was positive right over there. So it seems like this would be a reasonable view of the slope of the tangent line over this interval. Now let's think about as we get to this point. Here, the slope seems constant. Our slope is a constant positive value. So once again, our slope here is a constant positive value. Let me be careful here, because at this point our slope won't really be defined, because our slope, you could draw multiple tangent lines at this little point, this little pointy point. So let me just draw a circle. Let me draw a circle right over there. But then as we get right over here, the slope seems to be positive. So let's draw that. The slope seems to be positive, and although it's not as positive as it was there. So the slope looks like it is, I'm just trying to eyeball it. So the slope is a constant positive this entire time. We have a line with a constant positive slope. So it might look something like this. And let me make it clear what interval. Let me make it clear what interval I am talking about. I want these things to match up. So let me do my best. So this matches up. This matches up to that. This matches up over here. And we just said we have a constant positive slope. So let's say it looks something like that over this interval. And then we look at this point right over here. So right at this point, our slope is going to be undefined. There's no way that you could find the slope over or this point of discontinuity. But then when we go over here, even though the value of our function has gone down, we still have a constant positive slope. In fact, the slope of this line looks identical to the slope of this line. Let me do that in a different color. The slope of this line looks identical. So we're going to continue at that same slope. It was undefined at that point, but we're going to continue at that same slope. We're going to continue at that same slope. And once again, it's undefined here at this point of discontinuity. So the slope will look something like that. And then we go up here. The value of the function goes up, but now the function is flat. So the slope over that interval is 0. The slope over this interval right over here is 0. So we could say the slope over that interval, let me make it clear what interval I'm talking about. The slope over this interval is 0. And then finally, in this last section, the slope, let me do this in orange. In this last section, the slope becomes negative, but it's a constant negative. It's a constant negative, and it seems actually a little bit more negative than these were positive. So I would draw it right over there. So it's a weird-looking function, but the whole point of this video is to give you an intuition for thinking about what the slope of this function might look like at any point. And by doing so, we have essentially drawn the derivative over that interval.